Okay. Hi, my name is Muhammad Fitri Ben Zabani. My metric number is 08 DKM21F1 118.
Hello, my name is Muhammad Aiman bin Najib. My metric number is 08 DKM21F1141.
Hi, my name is Haris Kumar, anak lelaki S. Pramkumar. My metric number is 08 DKM 21 F1123.
Okay. To, Today, our group will present about apps of differentiation. Okay, first we go to the introduction of differentiation. Differentiation is the algebraic method of finding the derivative. Is a concept that is at the root of calculus. There are two ways of introducing this concept. The first one is the geometrical ways, as the slope of a curve. And the second one is the physical ways, as rate of change. The slope of curve translates to the rate of change when looking at the real life application. Either way, both the slope and the instantaneous rate of change are equivalent, and the function to find both of these at any point is called the derivative. The derived function represent first the rate of change of the function, next the gradient of the tangent to the graph of the function.
Next, we're going to see the basic rules of differentiation. The first rule is the constant rule, which is d per dx bracket c equals to 0. Why is it going to be equal to 0 is because in graph we have minimum and maximum points. So usually dy dx in graph minimum and maximum will be 0. Then next we have the power rule. Power rule is d per dx bracket x powered by n equal to nx powered by n minus 1. Usually we use this for basic differentiation. For example, when there's a y equation, it becomes dy dx and so on. Next, we have the constant multiple rule, which is d per dx bracket cf bracket x close bracket equals to cf prime bracket x. At this equation, we are going to differentiate the f, which is going to become f prime. So this is constant multiple rule. Then we have the sum rule and difference rule. Sum rule and different rule are the same, just that sum rule we are going to use addition and different rule we are going to use subtraction.
Okay, next, application in real life. First, in economics. In economics, differentiation can be used to calculate the rate of change of the ordering and transportation cost for the component used to manufacture a product, in which the cost is dependent on the order size. Next, in biology, differentiation is used in biology to evaluate the rate at which a bacteria population is growing. Next, in engineering, for describing the movement of electricity. Last but not least, in chemistry, for modeling chemical reactions.
Now we're going to see question 1. Diagram 4 shows the front view of a part of a roller coaster track in a miniature park. The curved part of the track of the roller coaster is represented by an equation y equals to 1 over 64x powered by 3 minus 3 over 16x square with point P as the origin. Find the shortest vertical distance in M from the track to ground level. This is the solution. So as the equation it says is y equals to 1 minus 64x powered by 3 minus 3 over 60x square. So we're going to differentiate this equation, which will give us 3 over 64x square minus 3 over 8x. Once we get this equation, we are going to find the x value of the equation. As we know that dy dx is going to be equal to 0, because either way, is it going to be minimum or maximum graph? Either way, it's going to be 0 for dy dx on the graph. So we're going to put 0 as dy dx. then what we will get is x equal to 0 and x equal to 8. So we will take x equal to 8 and we are going to find the value of d square y over dx squared to ensure whether the graph is going to be minimum or maximum. When we do that, our final answer is going to be positive 3 over 8. So if it's going to be positive, we're going to get minimum graph. Next, the fourth step is we're going to find the y value. So to find the y value, we need to take the original equation and we're going to substitute the x value, which is 8. So once we substitute it, we will get -4. So the coordinates will be 8, -4. Then the final step, we're going to draw a graph to show that what is the shortest distance from the track to ground level. So once we draw the graph, as you can see in the picture, we can see that from -4 to -5, the shortest distance will be 1 meter.
Okay, so we move to question number 2. Question number 2 said that the parametric equation of a curve are y equals 3 cos theta and x equals 2 sin theta. Find equation of tangent and normal to the curve at the point P where theta is pi over 4. So we have y and x. Y equals to 3 cos theta and x equals to 2 sin theta. Under the solution under the y is dy over dt equals -3 sin theta and dx over dt equals 2 cos theta. Next step is dy over dx equals to -3 sin theta multiplied by 1 over 2 cos theta. So the final answer is will be -3 over 2 3 over 2 3 over 2 tan theta. Dy over dx is equals to that -3 over 2 tan. So that the final answer will be 1.107 multiply 10 by -5. Okay, the tangent formula as we know is y equals mx plus c. The mx plus c is 1.107 multiply 10 by -5x plus c. And after all the solution, we will get y equals to, in bracket, 1.107 multiply 10 by 10 by 5 x plus 3. So the final solution is y equals to 9.033 multiply 10 by -6 x plus c. The last solution is the last answer is y equals to, in bracket, 9.033 multiply 10 by -6 x plus 3.
Okay, now we move to the conclusion. With the help of previous slides, we can conclude that differentiation is used in almost everything. With the use of differentiation, equipment like odometer, speedometer can be improved. So, differentiation is used to find change of one thing with respect to other. So, differentiation can help to make tomorrow better. Thank you from us. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Thank you, madam.
Thank you, madam.